So I thought I'd start back taking a look at this little ESP module, the ESP32 A1S. This module is interesting because not only does it have an ESP32 microcontroller, but it also has on board an ES8388 audio codec, all in the one package. And you can see that package is indeed quite small. I'm going to be covering this little module in two parts. The first part with the ESP IDF and ADF, the expressive audio dev framework. And then the second part, I think I'll go back to the Arduino audio tools, which I used before. So in this video, what I'll be covering is sort of a look at the physical characteristics of the device, how to hook it up and program it, the internal pin connections for the audio codec, and there are some mistakes in the documentation available, so I'll be covering those. And then we'll have two simple programs, one with a simple I2S program with IDF, and you've seen that before, that just simply emits a tone. And then the second one that I always like to use is the phase shift example, which I've used quite a few times using the ADF. So let's get straight on now and have a closer look at the physical device. Okay, so here's the basic device, and I got this one off Aliexpress. Each one of these is about $4, so quite cheap. Now you can see straight away that this is a surface mount package intended to be sort of soldered down to a board here rather than placing hookup wires. You can solder this. I've done it myself. You do need some fine gauge wire and a fine gauge soldering tip though. There are two varieties of this ESP32 A1S board out there. One with the ES8388 codec, which is what you're seeing right here, and one with the AC101 codec. Now, note that these two codecs are not compatible in any way. So if you want to do the sort of the examples that I'm showing here, you do need the ES8388 variety. So let's just quickly go to a site. There's a simple site out there that has a picture of both the boards, so you can confirm you're getting the right one. Okay, so you can see this site, which I'll include a link to, has both varieties of the ESP32 A1S, the ES8388, as well as the AC101. And you can see the differences between the two are pretty subtle. The RF can is identical in both cases, but on the AC101 variety, you can see the antenna is actually visible, as well as it has an IPEX connector. And on the back, the font is different, so you can see the difference. This is the ES8388 version, so you can see they're slightly different there. However, I did want to confirm my the modules that I purchased were the ES8388 version, so I took the can off, and let's have a look under the can. Okay, so here's two of the modules. Obviously, this is the one I removed the can from. I was able to coax it off with a hot air gun and some prying, hopefully non-destructively, but I haven't actually tried this module. And if you look closely, so here's the codec right here. Let me get my pointer out of the way. So there you can read that quite clearly, 8388. So this is definitely the 8388 version of the board, of the module. While we're here, you can see this is flash and PS RAM chips down the bottom here. Here's obviously the ESP32 core processor with the crystal and some attendant circuitry. So anyway, that does confirm that the variety I have is the ES8388 version. So while we're here, let's quickly have a look at what pins there are available on the module. Let's just get that turned around so we can see it. And you can see here, obviously there's a pile of IOs that are exposed here on this side and this side. But also we have here in these HP out R and HP out L, we have all the line in and line out from the ES8388 exposed too. So you've got the ES8388 has two lines in and 2 lines out, and each line in and line out has a left and right channel there. So all of those are exposed, which is great for experimenters like myself. In addition, you have these 2 pins here, RX D0 and TX D0. They'll come in handy later on when we get to programming this little module. And then over on this side we have the 3.3 volt power supply that you need to supply it. Now all these grounds here are all tied together, so you only need to hook up one of those to ground. Anyway, so that's the we'll go into some more detail on the pins later on, but that's sort of a high-level view of the pins that you have available on the ES83 on the module. Oh, just one item of note is IO0 is what the chip uses for the master clock. So again, we'll get to that in the upcoming section. Okay, so soldering directly to this little module can be done. As you can see here, this is all hookup wire here. It does need a fairly fine-tipped solder, but you know, you can definitely solder on here. Obviously not, this is not how it's intended to be used. It's intended to be sort of the other way around and surface mounted. But anyway, obviously for a more permanent installation, that's what you do. Okay, so let's move on to how to program the module. And I'm sure you've noticed there's no USB programming interface on the module itself. So if you want to program one of these modules, you're going to have to get a hold of the one of these USB to serial adapters, like this one here. These are, I'll include a link. They're all over Amazon. They're quite cheap. No affiliation as usual. So a couple of things to note with the adapter board is you're going to make sure, at least with this, that there's a little jumper here between that sets the output of the board between 3 and 5 volts. You want to make sure the jumper's over on usually on the right hand side here. That's 3.3 volts. The other thing to note is for auto programming, well, let's just lift this guy up and have a look at the pins here. So for auto programming, we'll be using the DTR and the RTS outputs. Now the RTS isn't on the pins down here, so I've had to attach this guy here. So you can see the other pins on here, RX and TX. So RX goes to TX on the ESP32, TX goes to RX on the ESP32, and then you have to make sure you're grounded as well. This VCC we won't be using. I'll be powering the board separately. Okay, so let's take a quick look at the schematic that we've got going here. So firstly, over on the left-hand side there is that piece of circuitry that allows you to automatically program the ESP without pressing any boot buttons or whatever. And you'll see this structure in a lot of the pre-built boards. So basically, DTR and RTS both come from the USB to serial, and then EN is the reset button on the ESP32, and IO0 is the so-called program button, which happens to be shared with master clock, but that doesn't matter. So on the output side, I'm using HP out R and L. Let's just zoom into that a little bit so you can see that. And I've got that, as I said, going through a simple low-pass filter to get rid of some high-frequency noise there. On the input side, so that's coming in through this jack here, through a pair of 0.1 microfarad decoupling caps into line in L and line in R. Now do note these decoupling caps are mandatory. If you don't have them, you can get all sorts of strange behavior. And then finally TX0, so RX from the USB to serial adapter goes to TX0 over here, and TX from the serial adapter goes to RX0, sorry, RXD0, which is there. And then finally a note, and this is kind of important because this is where the documentation that comes with the board is wrong. The documentation has an incorrect pin for the S clock or bit clock It's actually GPIO 27. And it's a bit mysterious on what GPIOs are used for the I2C to the ES8388, but what they are is GPIO 33 and is SDA, and GPIO 32 is SCL, and obviously you need to set that up in the code that you're using. So that's pretty much it on the on the schematic here. I do have a little push button here to allow me to reset the ESP32 if I need to, and like I said, I'll include a link to this schematic in my GitHub repo. Okay, so here's that all on the board here. So this here is the output jack, and the eagle-eyed of you will notice I have a little New Hampshire visitor here. It's a spider here, so he takes care of the mosquito, so I'm just going to leave him alone. So here's the output here through that low-pass filter. Here's the input here. I've shown you the board here before. Here's the USB to serial adapter, and then there's that pair of transistors which is used in the auto programming. And down here I have the reset switch. So that's all it ready to go. Oh, I did forget. This is the 3.3 volt regulator right here. Of course, you do need that. Anyway, so what I'll do next is I'll do a simple tone. I'll show the code for that, and then we'll see the output, and we'll take it from there. Okay, so here's the code here, and effectively what this code does is just it emits a simple 700 Hertz sine wave on both left and right channels, and it varies the amplitude up and down. So this is using the IDF, the ESP IDF. Like I said, in the next video I'll get on to doing the same with the Arduino. But you can see here I've got all my pin assignments right here for bit clock, word select, LR clock, and so on and so forth. And then just down below, this is exactly the same as the code that I used before in my previous video, which I'll include a link to, when I was using the PCB Artist 8388. It's exactly the same codec, fortunately. So I was able to reuse all that code pretty much without change, which is good once I had the pins figured out. So here's the piece of code down here that basically varies the amplitude. And then so what we'll do is we'll have a look at it on the oscilloscope, and we'll have a look at we'll hear it on the speakers. So that's coming right up. Okay, so here's the output there, and as you can see, I've got a pair of sine waves as expected at 700 Hertz, and you can see the amplitude of that is varying up and down. So just the final test will be to plug that into the speakers, and bear with me while I get this done. And you can hear that tone increasing and decreasing, and you won't be able to hear it, but it is actually happening on both channels. So that's the first example, simple sine wave varying amplitude. What we'll move on to next is my favorite example. Let me just turn this down. My favorite example, which is 90-degree phase shift. That's coming right up. Okay, for the phase shift example, I'm using this ESP32-IQ project, which is up on my GitHub repo, which I've used before. Just a few changes to note though. I'm using basically I've modified the Lyra AT 4.3. That goes in the audio board directory if you're familiar with how the ADF works. And basically what I've got in there's two files that I've changed. There's board.def.h, and in that I've changed the ADC input to audio HAL ADC input line 2, which corresponds to line in L and line in R on the board. So that's the change for this one. And then in board pins config, I've got the pins assigned that we talked about before. So here's the two pins for I2C, pins 33 and 32, and then here's the 4 pins for the bit clock, word select, data in and data out, the same ones that we had before in the other project, 27, 25, 26 and 35. The only other one to confirm is the master clock, and by default the ADF uses GPIO 0 for that anyway, so you don't have to change anything. Now, one other thing to note is if you, I do have 2 other files here that I had to fix earlier. I went through those earlier before, but there were some bugs in the driver for the ES8388 in the ESP80F, and they're still there. So, so I think you can just take a copy of that, and that goes in the audio HAL driver directory. And then the other thing is there was a problem with i2sstream.c, and that basically goes in audio. I'll put that in the project description where that goes, and that has a header file i2sstream.h and i2sstream.c. So you do need to update your ADF to for these guys here. And a little bit of a rant on the ADF itself is I like the toolkit, but it's such a pain to get set up. I installed it from scratch on this Linux machine here, and the latest version of the IDF, which is currently version 5, doesn't work with the latest version of the ADF. It's astounding. So I had to use IDF version 4.4, and then that works with the latest version of the ADF. So it's a great toolkit. I love it. There's just some bugs in it. Anyway, that's enough of a rant. I do like it, so I can't complain too much. Like I said, in the next video, I'm going to use the Arduino audio tools, and that's a lot more straightforward to set up and use. So anyway, let's move on now to seeing the output of the phase shift on the oscilloscope, and that's coming right up next. Okay, so here's the setup, and if I just pan up a bit, so I basically got my signal generator here emitting a tone on channel 1 and channel 2, 1 kilohertz tone on both channels. Now the phase offset between those two is 0 degrees. All the phase changing is done in the processor. That comes into line in left and line in right here through those 2 decoupling caps I mentioned. Gets processed on the ESP32, then it's coming out through that low pass filter, out through this line here and off into the oscilloscope. And let's just move over to the oscilloscope so you can see the output there. And there you can see the output with that sort of classic 90-degree phase offset between channel 1 and channel 2, between the left and the right, sorry. So interesting thing is I'm running this off a fairly noisy power supply, so you can see all the jitter and noise that's caused there. So let me just I've got a LiPo battery right here. Let's just plug that in, and you'll see a dramatic difference between the quality of the output signal. So you can see there all that noise has gone away. So anyway, just something to note there. So as you can see, the classic test will be to put that in XY mode. Should get a perfect circle, which we do get. Let's just change the frequency a bit. So I'll go up to 2 kilohertz on channel 1 and channel 2, and you can see still got that perfect circle. Let's go up to 3 kilohertz. There and there. And you can see from 1 to 3 kilohertz a perfect circle, well, close enough to a perfect circle. So anyway, that's all I've got for this video. I thought that would be of interest to people. A nice easy video to start the next series of videos, and hope you enjoyed this. Like I said, I'm going to follow this up with a a video that doing the same sort of thing, but with the Arduino Audio Tools library. So that will be coming up in the next day or so. Hope you enjoyed this. That's all for now.